Good day to everyone who's watching. In our lesson today of algebra, we are going to talk about the factorization of quadratic expressions. Remember, when we are talking about the expansion, we expanded some two brackets, and then later on we said that that expansion was a quadratic expression. So that is what we had in that example of the expansion, and we expanded by saying that is going to be x to multiply this bracket here, x plus 2, then plus 1 to multiply that bracket x plus 2 there. Then we open the brackets there to have x squared plus 2x, then plus 1 times anything is that anything. Then now we added the like terms, 2x to x to have 3x plus a 2 there. So the x plus 1 into the x plus 2, when we expanded, it gave us that. Now what we are going to do is that we are going to be given such an expression, and we need to take it back such that it can have brackets there. We shall be going through the steps just the way you see them. Now we shall be working backward in order to go back to that one there. That is, we need to get an injection of two numbers to replace one of them. Then from there you can easily factorize two terms there. So this number which we substitute there, we are always going to be calling it as the sum, and then we shall have also the product there. But before we go to that, there is that factorization of a number which is perfect. We normally call them perfect squares, using the identities a plus b squared is equal to our a squared plus 2ab then plus b squared. For example, I can be given the x squared plus 4x plus 4. It is in that format, already expanded. Now I need to write it as a factorized expression. So when you look at the a here is my x. When you look at here the 4 and the x there, we say the 4 is already the x, right? Then that means that the b should be in there in the 4, embedded in the 4. When I divide this 4, divide by the 2, I'll be having my b as a 2. Because on the expansion here, there should always be a multiplication of a 2. So I've identified my a as the x, then my b as the 2. When you look at the b squared there, gave you the 4. That means that b squared should be the same as 2 squared. When you take the root both sides, you have the b as a 2, and it is just initially the b I talked about there as a 2. So taking it back now, I'll be just writing x plus a 2 squared to give me that one there. So that is the expanded expression. This is the factorized one. I've just seen that this one here is a perfect square. Then I used the identity of the addition, and then go identified my a and the b. Then I substituted them back there. So our examples there factorize the following. Here we are going to identify the factors using the identities we looked at when we were expanding. My part A, x squared plus 10x plus 25. I'm going to write the perfect square to this expanded expression by using my identities there. So this expansion is in that form. So I just need to identify my A and the B, then write this side here. When you look at the A, there is my x. Then in this 10, there is a 2 embedded there. So when you divide, you'll be having a 5. Or the B squared there is equal to the 25 here. So that means that B alone is just 5. So I've said A is this x, the B is the 5. Now I just write A plus B squared. So the whole of x squared plus 10x plus 25 is now x plus 5 squared. My part B there, I'm having 4x squared minus 12x plus 9. So the identity that is having a negative there is the A minus B squared. Now I need to identify the A and the B. When I look at my A squared there, this one here is equal to 4x squared. So that means that my A alone, when you take root both sides, is going to be equal to the 2x. Then when you look at the B squared there is equal to the positive 9 here. So the B alone is a 3 there. Also, if I want to get my B using this and that one there, the negative 2AB is equal to the negative 12x there. The negative and negative can cancel out. The 2 is going to reduce the 12 to have AB is equal to 6x. Then now, when we substitute for A, which we got earlier here as the 2x times the B is equal to 6x, then we divide both sides by 2x and that side by 2x. You see you are getting the B as 3, which is that one there. So I'm going to finally write my factorized expression as the A, which is 2x, then minus, because this one here was also a minus, the B, which is a 3, then I shouldn't forget the square there. Part C, this part here is positive, so this I use the identity up there. My A squared is the same as 9x squared, so that means that when I take the square root both sides, my A is 3x. Then when I look at the B, the other side, which is squared, here it is equal to positive 16. That means that my B now is the same as a 4. Therefore, the 9x squared plus the 24x plus the 16 is equal to 3x plus 4 brackets squared. Part D, we have 36 minus x plus 2 squared. This one we looked at in the previous lesson using the difference of 2 square, that is this identity here. So the 36 is the same as 6 squared, then minus x plus 2 squared. Then now I can substitute these two in there. My A is the 6, and then my B is the whole of x plus 2. So this is 6 plus x plus 2. Then another bracket, 6 minus x plus 2. This one here, I've not put the bracket because the positive cannot affect whatever is inside the bracket. But for the negative, I've put the bracket because I know the negative can affect whatever is inside the bracket. So now simplifying each bracket, 6 plus 2 is the 8 plus x there. Then the other one, when you open the bracket, that's going to be 6 minus x minus 2. So if you did not put the bracket, you'll be having this one as positive. So simplifying the other bracket there, we have 6 minus 2 to get positive 4, then minus x. So I have there another bunch of examples, and here we are going to use the sum and the product. The general quadratic expression is in the form ax squared plus bx then plus c. So here at O level, we are going to take the sum as the b, that is the positive b, we go with the sign which is there. Then we shall take the product as the a times the c, because there is some coefficient of the variable x there. This expression here has this part here, which we call the quadratic term. Then we have this part here, which we can call the linear term. Then this part here, we can call it the constant term. So these examples here, you cannot use the idea of the identities like we have used in the previous ones. So you just need here to identify the sum and the product. We have said the sum is that coefficient of the linear term. So our sum is positive 9. Then the product becomes, the coefficient here is 1 times the constant term, which is 20 there. So now from here we need to get two factors that give us an addition of 9 and a multiplication of 20. To get those two factors quickly, you can first list down the factors of 20. So factors of 20, there is a 1, there is a 2, there is a 4, there is a 5, there is 10, and 20 itself. Now, when you look at those factors there, you need to remove two numbers that when you multiply you get 20, and when you add you get the 9 there. So for me, when I look at them, I'm seeing those two there. So my factors are going to be 4 and 5. 5 is positive and also 4 is positive. When I add 4 plus 5, I get positive 9. When I multiply 4 times 5, I get positive 20. So there, I'm going to now to substitute those two factors there. Here where there has been the sum, so the x squared plus where there has been the sum, I put there a 4x, then plus 5x, then plus the 20. Now you are seeing that now these terms have been 3. Now they are 4. So these 4 I'm going to group to 2, or I'm going to factorize to 2 at a go. So this here and there, x is common. So when I pull out the x, I'm having 1x there left, then plus a 4 here. Then now, when I look at these two terms, 5 is common. I'll be having x plus a 4 there, because when you multiply 5 times 4, you go back to 20. Then when you look at these now two terms which I'm having, you can see a bracket of x plus 4. X plus 4 is common. Then also that bracket, I'm going to pull it out or factorize it. So when I remove it here, I'll be left with x. When I remove it there, I'll be left with positive 5. Then into that x plus a 4. Then I cannot factorize any further, so I stop there. When you look at this process, you can see that it is the process that we went through. When you go backward, you can see that it's the process that we went through to get the expansion of this. We say that that x multiplies that bracket, which is this, and again the positive 5 multiplies the same bracket, which is that. Then on the next step, you expand it, you open the brackets. That is why when you pull out a factor here, make sure that when you reopen that factor with those things inside the bracket should give you the values on the previous step. My part B, identifying the sum. This is positive 7. Identifying the product. This is 2 times negative 9 to have negative 18. So I said that those two factors you are looking for, they come from factors of the product. So you can first list down factors of 18. Now when you list down those factors, you can see that the 2 and a 9, they can give you the product of 18. And when you manipulate both of them, they can give you an addition or a sum of positive 7. So my factors there, they are going to be now negative 2 and positive 9. When I add them, they are giving me positive 7. When I multiply them, they are giving me 18. Then there, I substitute them here where I've got the sum. So this one gives me 2x squared minus 2x plus 9x, then minus 9. I have 4 terms now. I factorize 2. So the first 2, what is common there is the 2x. When I pull out the 2x, here I'll be left with x minus, when I pull out the 2x, here I'll be left with a 1. Then plus, here the factor there is 9. When I pull it out, I'll be left with x there, and there with a minus 1. 2 terms, I'm still having a factor there, which is the bracket of x minus 1. So when I factorize further, this will be 2x plus 9, then into the x minus 1. So always this bracket shall be the same. If it is not the same when you are working out, please don't force it to be. That means that the factors that you used here, they were not the actual ones. So you just need to go back here, check again your factors, substitute them again, and then everything is going to work out itself. But see there, I'm having 2 unknowns there and a figure of 2. So even here, you can easily factorize that. So taking the x as the variable, then the y as a constant, the sum is going to be negative y. The product is going to be 2 times negative y squared. So that gives me negative 2y squared. Factors here, you have negative 2y and y. So when you get negative 2y plus y, this one you get minus y. When you get negative 2y times y, you get negative 2y squared. So my factors are okay. Then I'm going to substitute them here where I'm having negative xy. So this one is going to be 2xy minus the 2xy, then plus the xy, then minus y squared. I'm adding on the x there because we took x as the variable there. So factorizing 2 terms, I'm having 2x as a factor there. Then when I remove it out, here I'll be left with 1x, then a minus, there I'll be left with a y, then plus, when I factorize here, y is common. When I pull it out, here I'll be left with x minus y. You can see that this bracket is the same as that bracket. So factorizing further, this is going to be 2x plus y into the x minus the y. As simple as that. So even here, the sum is the negative 12b if I take a to be the variable. The product becomes 2 times 18b squared, and this one here gives me 36b squared. So I need to get 2 factors that can give me this product and that sum there. So minus 6b and minus 6b, when I multiply them, I'm having 36b squared. When I add them, I'm having negative 12b. Then I'm going to substitute them here. This is going to be equal to 2a squared, then minus 6ab, then minus 6ab plus 18b squared. Factorizing 2 terms, 2a is common, so here I'll be left with only a. Then here I'll be left with 3b. Then factorizing these 2 terms, minus 6b is common, so here I'll be left with a positive a and then a minus 3b there. I think it is somehow confusing, but when you open the brackets, you see that the positive and the negative 6b will give you negative 6ab, and then the minus 6b times the positive 3b will give you a positive 18b squared. That and that bracket, they are the same, so I factorize further. So here I'm left with only 2a, then there I'm left with only negative 6b, then into a minus 3b. Then I can factorize the x squared plus 4x minus 5 there, identifying sum, positive 4, identifying the product, negative 5. The 2 factors, they come from factors of the product. Factors there, 5 is a prime number, has only 2 factors, that is 1 and the 5 there. Now the 1, I'm going to manipulate them such that I make the 1 to be having a negative, such that when you add, you get positive 4, and when you multiply, you get negative 5. So this one here is going to be x squared. We substitute those two factors here, minus x, then plus 5x, then minus a 5 there. Factorizing two terms, so this is x into x is common here. Here we left with x minus a 1. Then here the factor is positive 5 into x minus 1. When I factorize further, I'll be having x plus 5 into x minus 1. So I can have this one here, x squared minus 5x, then minus 6. Identifying the sum, negative 5. Identifying the product, negative 6. The factors come from the factors of 6. So that is 6 and 1. Now I need to manipulate one of them to suit these two conditions. So that is, I negate the 6 there. When I add it, it gives me negative 5. When I multiply, it gives me negative 6. Then now I substitute them in there. So this is x squared plus x minus 6x, then minus 6. So I factor out x here. Here I'll be left with x, then plus 1. Then here, negative 6 is common. So that is minus 6 into, the rest are going to be positive, because when you reopen, we will go back to negative. The negative will affect whatever is inside there. Then that bracket and that one, they are the same. So when I factor it out, I'll be having here x, then there negative 6 into x plus 1.